Hello friends, myself R.D. Mahajan presenting my video on complex number revision part 3. First example, if cos of theta plus I phi is equal to r into cos alpha plus I sin alpha, then prove that phi is equal to 1 by 2 log of sin theta minus alpha divided by sin of theta plus alpha and log to the base e. And therefore, to prove this, we take the help of the given. Left hand side is cos of theta plus I phi, and that is equal to r cos alpha plus r into I sin alpha. Expanding this by cos a plus b, we get cos a cos b means cos theta cos I phi minus sin theta sin I phi, and that is equal to r cos alpha plus I times r sin alpha. This cos I phi is nothing but cos h phi, and this sin I phi is I sin h phi. Remaining terms as it is. Therefore, this cos theta as it is, and here it's sin theta as it is, and that is equal to r cos alpha plus I times r sin alpha. A complex number on left hand side and equal to another complex number on the right hand side. Comparing real part with real part, we get therefore cos theta cos h phi is equal to r cos alpha, and imaginary part minus sin theta into sin h phi is equal to r sin alpha. Divided by this, we get therefore cos theta into cos h phi whole divided by sin theta sin h phi, and that is equal to minus r cos alpha divided by r sin alpha. This minus sign we take on left hand side only, and therefore simplifying it, transferring this cos alpha by sin alpha to left hand side, we get cos theta into sin alpha divided by sin theta into cos alpha, and that is equals to minus cos h phi divided by sin h phi. We transfer to right hand side, it becomes sin h phi divided by cos h phi. Therefore, sin h phi divided by cos h phi is nothing but tan h phi, and that is equals to minus cos theta sin alpha divided by sin theta cos alpha. Then transferring this to right hand side, we get phi equal to tan h inverse of cos theta sin alpha divided by sin theta cos alpha. We have another standard result from hyperbolic function. Tan h inverse of inverse hyperbolic function. Tan h inverse of x is equal to 1 by 2 log of 1 plus x divided by 1 minus x. And using this result, we can rewrite that phi is equal to 1 by 2 log of 1 plus x minus cos theta sin phi sin alpha divided by sin theta cos alpha, and divided by 1 minus x, x is minus cos theta sin alpha divided by sin theta cos alpha, and therefore it is equals to 1 by 2 log of cross multiplying by sin theta cos alpha, we get sin theta cos alpha, and this plus into minus, we get minus cos theta sin alpha whole divided by sin theta cos alpha, minus minus it becomes plus cos theta sin alpha, and to the base e. Then sin a cos b minus cos a sin b is nothing but sin of a plus sin of a minus b. Therefore, it is theta minus alpha divided by sin a cos b plus cos a sin b is sin a plus b. Therefore, sin of theta plus alpha, and that is equals to phi is equal to, we get 1 by 2 times log of sin theta minus alpha divided by sin theta plus alpha to the base e. We get the required result, hence proved. Second example, prove that tan of I times log of a minus ib divided by a plus ib is equal to 2ab divided by a square minus b square. And therefore, to prove this, we consider this log term given is log of a minus ib whole divided by a plus ib. Log a by b is log a minus log b. As per that, it is log of a minus ib minus log of a plus ib. And then using the definition of principal log value, we have log of x plus iy as log of r plus I theta, where r is root of x square plus y square and theta is tan inverse of y by x. Therefore, using this, we get this log a minus ib is log of r. R is here root of a square plus b square plus I times theta. Theta is tan inverse of y by x minus b by a, and minus log of a plus ib, again log r. R is here root of a square plus b square and plus I theta. Theta is tan inverse of b by a, and therefore it is equals to this log minus log get cancelled. This minus I times tan inverse of b by a, and again minus I times tan inverse of b by a. Addition of this two is minus 2i tan inverse of b by a. Then multiplying both sides by I, therefore we get I into log of a minus ib whole divided by a plus ib, and that is equals to I into I, it becomes I square, therefore minus 2i square tan inverse of b by a. This is I square is minus 1, minus minus it becomes plus, therefore it is 2 times tan inverse of b by a. Two times tan inverse of b by a we can write down as tan inverse of b by a plus tan inverse of b by a. Therefore, it is tan inverse of b by a plus tan inverse of b by a, and that is equals to the standard result. Tan inverse of a plus tan inverse of b is tan inverse of a plus b, means b by a plus b by a divided by 1 minus ab, means it is b by a multiplied by b by a, and therefore it is tan inverse of b by a plus b by a, we get 2 times b by a whole divided by cross multiplying by a square, we get a square minus b square divided by a square, that goes to numerator, and then transferring this tan inverse to other side, we get tan of I times log of a minus ib whole divided by a plus ib, and that is equals to 1a get cancelled, therefore remaining terms are 2ab whole divided by a square minus b square, a square minus b square. Hence proved, we get the required result. Therefore, that required result is tan of I times log of a minus ib divided by a plus ib is equal to 2ab divided by a square minus b square. We get the required result. The important thing is this definition of log z in principal form. A principal value of log x plus iy is log r plus I theta, where the value of r is the root of x square plus y square and theta is tan inverse of y by x. Applying this, we find the value of log of a minus ib and log of a plus ib, and then simplify to get the required result. Last example, third example. Solve equation x raised to 7 plus x raised to 4 plus x cube plus 1 equal to 0, and to solve it, we consider the given x raised to 7 plus x raised to 4 plus x cube plus 1 equal to 0. From first two term, I can take x raised to 4 common. Remaining terms here x cube, and here 1 remains, and plus x cube plus 1, and that is equals to 0. From this two term, I can take x cube plus 1 common, and therefore x cube plus 1, and remaining terms are x raised to 4 plus 1. Means we have two factors for this equation, x cube plus 1 equal to 0, that is x cube plus 1 equal to 0, and x raised to 4 plus 1 equal to 0. And we try to obtain the values of x for this equation as well as for second equation. And therefore, from the first equation, we get x cube is equal to minus 1. Converting in polar form, this is nothing but cos pi plus I sin pi. The value of cos pi is minus 1 and sin pi is 0, therefore we get minus 1. Then converting in general polar form, it is cos of 2n pi plus I times sine of 2n pi plus pi. From this two term, I can take pi common. Therefore, we get cos of 2n plus 1 times pi and plus I times sine of 2n plus 1 times pi. And transferring this power 3 to right hand side, we get therefore the value of x as a cube root of this. Therefore it is cos of 2n plus 1 times pi plus I times sine of 2n plus 1 times pi, and this bracket raised to 1 by 3. And then applying De Moivre's theorem, its expansion is cos of 2n plus 1 times pi by 3 and plus I sine of 2n plus 1 times pi by 3, where the values of n are 0, 1, 2, 3 values. And then when we substitute the first value for n equal to 0, we get the first root x0 is equal to n equal to 0, this becomes 0 plus 1 means cos of pi by 3 plus I times sine of pi by 3, and that is equals to cos 60 1 by 2 plus I times sine 60 root of 3 by 2. Therefore this is the first value. Then for n equal to 1, we get x1 is equal to 2 plus 1, 3 into pi by 3, it becomes cos of pi plus I sine of pi. Value of cos pi is minus 1, sin pi is 0. Therefore the second value is minus 1. And lastly, for n equal to 2, we get x2 is equal to, put n equal to 2, 2 to the 4, 4 plus 1, 5. Therefore it is cos of 5 pi by 3 plus I times sine of 5 pi by 3. This we can rewrite as cos of 2 pi minus pi by 3, 3 to the 6 minus pi, we get cos of 5 pi by 3 and plus I times sine of same 2 pi minus pi by 3. And that is equal to cos 2 pi minus theta, cos of 2 pi minus pi by 3 is cos pi by 3, and sin 2 pi minus pi by 3 is minus sin pi by 3, and therefore substituting the values, cos pi by 3 it is 1 by 2 minus I times sin of pi by 3 is root of 3 by 2. Therefore these are the roots. First one 1 by 2 plus I times square root of 3 by 2. Second value is minus 1, and the third value is 1 by 2 minus I times square root of 3 divided by 2. These are the values for the first equation, x cube is equal to minus 1. Then we try to solve the second equation. Second equation is x raised to 4 plus 1 equal to 0. Transferring to right hand side, we get x raised to 4 is equal to minus 1. Converting in polar form, this is nothing but cos pi plus I sin pi cos pi is minus 1, sin pi is 0, therefore we get that value as minus 1. Then converting in general polar form, this is nothing but cos 2n pi plus pi plus I times sine of 2n pi plus pi taking pi common, we get cos of 2n plus 1 times pi plus I times sine of 2n plus 1 times pi. Then taking fourth root on both sides, therefore we get the value of x as cos of 2n plus 1 times pi plus I times sine of 2n plus 1 times pi, and that raised to 1 by 4. Applying de Moivre's theorem, the value of this or expansion of this bracket is cos of 2n plus 1 times pi by 4 and plus I times sine of 2n plus 1 times pi by 4. Second equation. And then where the values of n are 0, 1, 2 and 3, 4 values. We get for n equal to 0, first value as cos of n is 0, therefore remaining term is cos of pi by 4 plus I times sine of pi by 4. And the value of cos pi by 4 and sin pi by 4 is 1 by root 2. Therefore, it is 1 by root 2 plus I times 1 by root 2. That is first value. Then for n equal to 1, we get next value x1 as 2 into 1, 2 plus 1. Therefore, it is cos of 3 pi by 4 plus I times sine of 3 pi by 4. Converting cos 3 pi by 4 we can write down as cos of pi minus pi by 4 and sine of pi minus pi by 4. And then standard result cos pi minus theta minus cos theta, and therefore it is minus cos of pi by 4, and sine of pi minus theta is sine theta, means sine of pi by 4, and values therefore cos pi by 4 is 1 by root 2, therefore with minus sign, and sine pi by 4 is 1 by root 2, therefore I into 1 by root 2 as a second value. For n equal to 2, we get x2 next root cos of 2 to the 4 plus 1, 5, we get cos of 5 pi by 4 plus I times sine of 5 pi by 4. That we can rewrite as cos of pi plus pi by 4, 4 pi plus pi, we get 5 pi by 4, and plus I times sine of pi plus pi by 4. It is equals to cos pi plus theta is minus cos theta minus cos of pi by 4, and sine pi plus theta is minus sine theta, means sine of pi by 4. And then substituting the values of cos pi by 4 and sine pi by 4. First one is 1 by root 2 with minus sign, and minus I times the value of sine pi by 4 is also 1 by root 2. And then lastly, for n equal to 3, we get x3 is equal to cos of 3 to the 6, 6 plus 1, we get 7 pi by 4 plus I times sine of 7 pi by 4. Nothing but cos of 2 pi minus pi by 4 and plus I times sine of 2 pi minus pi by 4. That is equal to cos 2 pi minus theta is cos theta, and therefore it is cos of pi by 4, and sine of 2 pi minus theta is minus sine theta, therefore sine of pi by 4. To minus I times value of sine pi by 4 is again 1 by root 2. Therefore these are the values for second equation. First one is 1 by root 2 plus I times 1 by root 2. Second value is minus 1 by root 2 plus I times 1 by root 2. Third one, minus 1 by root 2 minus I times 1 by root 2. And the last one, 1 by root 2 minus I times 1 by root 2. These are the values of x, or that is the required solution of the given equation. If you like my video, please share it as well as subscribe to my channel, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.